So, good morning, everybody. I have the responsibility to open this second day of the first BotConf. So first, I will thank you, Eric, and all this team for the great organization and especially for the event yesterday evening. I thank you, the few survivors, to be here this morning. I know it's tough, it's early for most of us. Coffee is coming after the break, but I will try to wake you up smoothly. So, as said Eric, I will present Perdix, a framework we have developed to perform behavior analysis on security threats in cloud computing environment. So, I can lose a bet, so I was forced to put my photo on the slide. I think it could have been worse, but anyway. We are a security expert company since 7 years. Our historical business is based on security service, such as penetration testing, forensic analysis, and so on. And since 2012, we have developed IKEA, vulnerability assessment and security monitoring tool. And for myself, I'm a security expert for 10 years. I'm specialized in mobility and cloud computing security. And I'm also ITRUST here. So a word about the context. During the last few years, malware and attacks have become more and more targeted and smart to avoid and bypass traditional security measures such as a firewall and IDS. And this threat uses all means possible to exploit vulnerabilities from social engineering to zero-day. And in parallel to these trends, the volume of digital logs by security products have drastically increased, such as big data analytics has emerged to perform behavior analysis and to detect those threats. So that's great. We are capable of identify advanced malware in closed environment with the logs and the data flow. But what about the cloud environment? The security products that are working on closed environments are not really adapted to cloud environments since there is no log available and the data flow are not available also. So we arrived to the conclusion that there is data that we can collect externally in cloud environments. We are able to collect this data, and we should be able to analyze all this data and perform behavior analysis on this. So this is the idea Perdix is coming from, and I will present you this framework. So Perdix is based on two modules. The first one is the data collector, which will be responsible for the capture and the storage of data we are able to collect externally in the cloud. And the second module is the engine, that is responsible for the analysis. So the data collector is based on IKEA, our vulnerability assessment tool. So the first data we are able to collect, obviously, is security elements. So we can discover and identify the service running on cloud infrastructure through scan. And we are also able to detect known vulnerabilities on this infrastructure and on application. And finally, we are able to identify security misconfiguration, such as the default password on equipment, such as anonymous access on FTP, for instance, OpenShare, etc. Then we have added to the security scanner quality of service scanner, which will poll cloud infrastructure to evaluate the service availability and their response time. So that to plug on cloud provider API to collect other data like bandwidth usage. So just a tiny parenthesis on IKEA. It's the data collector, but it's also providing a security dashboard to see if you have non-vulnerabilities on your application and your infrastructure. And the user has the opportunity to patch this vulnerability and limit the attack surface to 0 day and non-vulnerability. The end of the practice. So the second part of the framework is Perdix, which is the engine responsible for the data processing and analysis and the data visualization. So this engine is based on statistical analysis and the seasonality of data. The aim of this engine is not to summarize the data and create an average value, but to use the data set to learn about the normal behavior and to detect abnormal behavior. At the end of the analysis, we create a data profile with an estimate that best approximates the normal value and a confidence interval that contain the majority of the observed data. Then we have the correlation part. We are able to reduce false positive, to infer relationship and dependencies between multidimensional data sources. And finally, we are able to perform prediction based on the data we are collecting. Finally, we also provide an expert system rules. The goal of these rules are to provide a pre-learning information to ease the constitution of the statistical model. So in fact, this Perdix framework is not limited to sample the dataset. We are not reducing the data, but it uses complex analysis such as predictive algorithm and pattern matching elements. So we have decided to present the framework very quickly, and the idea is to see with a practical example how it can help to detect advanced malware. So what we have done, we have created a lab with Perdix, and we have inserted a non-malware to see how we can collect the data and see if we can detect its activity. So the malware behavior, it's based on a non-PHPBD remote code vulnerability. Once it's exposed to this vulnerability, the bot is downloaded from a remote CNC server. It opens an ERC server, and then it runs its malicious command in the infrastructure it's installed. So it will first scan all the assets on the network to find shares that are open, and the ones that are not open, it tries to brute force them with default account, administrator, etc. And at the end, it tries to download the data it can access on this share and upload to the server. So the first part of the analysis is the security analysis. It's based on a non-PHPBD vulnerability. So obviously the vulnerability scanner will have detected. Let's say the administrator is not really careful and let this vulnerability open. Once it is exploited, it opens an ERC server to contact the CNC server. So the security scan will also detect the open port. So that's the two basic things we could have identified without analysis. And then with the analysis, in fact, as I said earlier, we provide pre-learning rules. So, for instance, for security, these rules are providing a profile with credible service supposed to be found, depending on the server role. So for instance, you have the web server profile. We're providing with the rule. These rules are not enrated. It's learned from the different scanner we have done on infrastructure. We have learned several profile, and this is an instance for the server profile. So as you can see, obviously you have an 100% chance to find an HTTP server on the web server, but you can also find HTTPS, SSH, etc. But anyway, an ERC server is not part of this profile. So the analysis flag the security behavior as a normal. So we flag the data as a normal, but we don't necessarily raise an alert. I will show you after how the alert is raised. The second part of the analysis is the quality of service analysis. So once the bot or the malware is running, it tries to scan and reinforce the infrastructure. So the resources used to scan internal infrastructure will slow down the treatment of legitimate requests. And as you can see on the visualization of data, in gray, it's the data when the malware is running. So you can see it's out of the regular profile. So as I said before, the normal behavior is based on the predictive analysis. And it's not just a smooth average of data, which would, for instance, may disappear possible slight acceptance deviation. For instance, if you have a maintenance operation once a month, you are patching the server and restart the server. In the data, you will have a response time slightly different to the normal, and you will have the availability. The server will go down. If you have a smooth and average mean, you will raise systematically an alert. But what we are doing here is learning from the data. So the comportment of maintenance will be in the learning process, and we won't raise an alert. But for this event, it's not a learned profile, so we are also raising an alert that it's not a normal comportment. Another analysis we have made is based on the bandwidth analysis. So when the bot is downloaded on the remote server, we could not see it, and the bandwidth usage was not so different from the average bandwidth. So we won't. It's not significant enough to raise a flag. But when it shares and tries to download the data and upload the data collected to server, we are able to flag this as a normal. As you can see, once again, you can see that the gray visualization is out of the learned profile. And another interesting statistical analysis is that we can sort data depending of their seasonality. For instance, in bandwidth usage, we are able to see if it's in the learning process, if it's working day. If it's a weekend, we are able to analyze that it's a public holiday or holidays, and we are able to refine the analysis with the correct sample. So, for instance, you have the profile we have made of a working day, and we are able to see that the behavior is abnormal for a working day. Yesterday, when we talked about the banking program, the speaker explained that most of the time it happens the weekend when the guys are partying. With this analytics, we normally the weekends there is no activity, so as soon as there is something happening on the network, we would have been able to see it. So we have flagged several behavior as abnormal. And the interesting part at the end is to see how we are able to alert the user. So the most important thing is in this example, but in real life, so is the alerting system. We could have the best analytics system if we are not capable to correctly alert the user. It's useless. So deviant behavior should be reported with sufficient information. It's vital for the user that he will be able to visualize the data responsible for the alert, to know exactly what triggered the alarm, and which is the beginning, where is the beginning of the attacks. So in this case, we have sufficient flags to raise an alert, and as you can see, it's a kind of alert we are able to raise. The important thing is that it's in natural language, so everybody can understand what happened. So for this example, you have all the points that have raised the alert. So a vulnerability is detected on the server, a new service is detected. The service does not correspond to the long profile and the normal behavior. The server response time is out of the threshold, and the bandwidth exceeds the normal behavior. So when the alert is raised, the user will have also the availability to see the data profiles that I've shown before, and to see exactly what is happening. To conclude, this framework is still in R&D process, but the combination between statistical and learning algorithms provide an efficient tool for us to detect unknown security issues in cloud environments. And the preliminary results we have on our lab, we have run several malware, and the implementation of the framework forecasting is really promising. So we have great hope on this framework. So the next part for now, it will be tested on real environments, so then we can gather data and which are requested to train our behavior analysis module, and to provide more and more pre-learning rules, so that when it will be installed on production, it don't take much time to learn behavior and to be efficient very quickly. So first version of this framework will be available in mid-2014, as it is included in a French government call for project called Secure Virtual Cloud. So we are working on this project to provide a secure framework for our cloud provider, in which this framework will be available to provide dashboard and security and alerting on security threats. It's been a little quicker than expected. I don't know if you have questions.
Okay. Morning questions?
Yes. Okay. So you mentioned forecasting. What are you forecasting? First question. Second question. You rely on the user to act, right? So I mean, if so it means you're expecting the user to, I understand it's natural language, but to understand the level of risk.
For the first part of the forecasting, in fact, as we learn the profile, we are when the first thing is when we are attending new data, we are forecasting on the predictive value, and we can differ between the expected value and the real value. And we are also trying to internal environments to predict, but not for the security part, but for the configuration part, to know when the server will be insufficient and the user will have to provide more memory, more CPU, etc. So it's kind of. And the second part of the question, we try to make it as ergonomic and comprehensive as possible. We try to provide the risk analysis as much as possible, but at the end, the user have to understand the level of risk depending on the server risk. So we are trying to provide a risk on the analysis, but at the end, it's the user to know whether it's risky for him or not.
My name is David. I was wondering what data sources you're tapping into at this time with this platform.
For the cloud environment, we are tapping on security information extracted from ICA on quality of service data. And we are also connected to cloud provider API, so every data we can collect on this, we collect it. And we are also trying to get information on fingerprinting, for instance, the web page, to see if the iframe are inserted, or if the page, new JavaScript is inserted in the page, etc. But we are also trying to do it on closed environment with the log, with flow value, but it's not for the cloud part.
Another question? Okay. Thank you very much.
Thank you.